Hello everyone, welcome to this Corrosion Stream 1 for the 14th of October 2020. This is a short video stream to describe for the undergraduate CET Part 2A Corrosion course what course material is available in terms of PowerPoints, PDF documents and videos, where you can find it on Moodle, YouTube, or GitHub. You can find all of it from Moodle, and where you can post comments or questions about course topics, answer underneath this video live stream, please. There are just 8 nice lectures for this course. And the videos for this course I actually made in 2017. The material covered is identical to the material we will cover in 2020. Let me just bring up my stream comments for a second. If you happen to be listening in the chat, please do bash F, just so I can see if there is anyone listening in on this, or something like that. So, course material for CET 2A Corrosion. Assuming you are taking the course, you can log into Moodle, then you can find these resources here and links to the video lectures on YouTube. So, resource number 1, so PDF lecture notes on Moodle. You can get 2 PDFs. Handout number 1 corresponds to the Introduction to Corrosion and the Algebra for the Thermodynamics and Electrochemical Kinetics of Corrosion. Handout number 2 builds on that, and its descriptions of real-world corrosion phenomena and real-world corrosion protection mechanisms. There's also the problem sheets, so problem sheet 1 corresponds to handout 1, and it's mostly on algebra of corrosion. Problem sheet 2 corresponds to handout 2, and it's on descriptive short note type answers about what are some corrosion problems and how do you prevent them. From the Moodle site you can also download the PowerPoint slides for all 8 lectures, from which you can annotate the lecture notes, and from the Moodle site you can follow a link to the YouTube playlist which has my audio recordings of all 8 lectures, with the slides as video content. You can use the video lectures just as well, hopefully better, than the PowerPoint slides to annotate your lecture notes, and hopefully listening to the audio description will be more useful to you than just reading from the lecture handouts and PowerPoint slides. One warning, as I said, the video lectures are made using the 2017 version of the lecture notes. There are some very slight improvements in the 2019 notes, such as the wording in thermodynamics in Chapter 2, Section 2.6, but the concepts covered are identical. In addition to the 8 video lectures on YouTube, there is 1 video supervision on problem sheet 1, which is there to prevent me from having to go through exactly the same algebra every year. Okay. So that's the material which is available and where you find it. If you don't have the access to the Moodle website, you can follow links from the video captions on YouTube to get the 2017 notes off of GitHub, and you can get the variant problem sheet number 1 and my sample solutions from GitHub as well. Okay, let me check my stream comments. That's fine. Actually have some viewers. Somebody do feel free to put a question into the chat and I'll see if I can read it, if you can think of any questions. If not, I'll carry on talking. So, by the way, can you hear this? Is a question. I assume that you can hear this because my recording works perfectly. However, if it can't, then I will have to do something by... I will have to hack about later. Assuming that people can hear, that's fine. If you can't, I'll figure out the audio and fix any problems with that later. So I described where you can get course material and what it is. Video lectures. Okay, so the video lectures, if you go to the playlist from Moodle, or you get to it directly through YouTube, video 1 is, what is this corrosion course about? What are the important concepts? Why is corrosion important? What are you going to be dealing with in the rest of this course? Video lectures 2 to 5 correspond to handout 1 and problem sheet 1. These are on does corrosion happen, and how quickly does it happen, as an algebraic exercise. Videos 6 to 8 are explanations of corrosion problems and corrosion protection mechanisms, corresponding to the second handout and problem sheet. Corrosion Supervision 1 is my sample solution for a variant version of problem sheet 1. Naturally, please do try your own solutions to problem sheet 1 before you look at my beautiful and flawless solutions, possibly flawless. If you don't, well, it's up to you. It's distance learning. It's the 21st century. The brave new world. Now, so just some comments on the video solutions to my problem sheet 1. This video solution is actually on a variant version of problem sheet 1, so it's the same mathematical problems, but with different metals and different numbers. So don't, obviously you wouldn't expect to be able to just directly copy the numerical solutions, but you should use it once you've had a go for it for yourself. If there are any bits of algebra you want to check on, you can go through and see how I did it. In the video I also give some comments on common mistakes and misunderstandings that students have, including on what is the difference in the way that I should be dealing with and writing in algebra volts, SHE, and just volts. There is a proper way to do that. Watch the video, and that's how you should do it. My sample solutions for this problem sheet are provided as is. There's a lot of algebra. I can't promise it is free from typos. If you do find typos, please post them into the into the comments section under the video, and I will try to respond to them and fix the sample solution for some future version of the course. Hopefully you don't find any typos, ideally because there aren't any. So that's the video on the algebra question sheet. The second question sheet is more on descriptions and explanations, so I didn't do a supervision on video by that, because how you do your explanations is a more personal thing, so you can discuss that with your supervisors. The algebra does have a correct way to do it, so it's useful to have up a standard reference of how you should be doing it. How to post questions about this course. Ideally post them in the comments section under Corrosion Stream 1, or under Corrosion Supervision 1, the video for that. You can post them under the individual lectures, but I might find it harder to distinguish between new questions and questions from a couple of years ago if you post them there. If you particularly want me to look at a topic question in someone's post, upvote it, and I will aim to answer popular questions in an upcoming stream. There is one scheduled for the 4th of November 2020, and I will try to sorry, I'm trying to do too many things at once. I will try to answer questions that you post into the comments of that stream in a upcoming video. Right, now, so reading my comments in the chat, thanks very much for your questions. Would you be able to get printed lecture notes for the majority of us who won't be able to annotate the notes electronically? I cannot do that because I don't have physical access to the department where I would normally do my mass printing of lecture notes. You are very welcome to ask if ask through the teaching office in the department if printed versions of the PDFs could be made from Moodle. I'm sure that or you're welcome to print them yourself, depending on whether you don't mind spending money on all of the dead trees. It's genuinely, I genuinely think I always found it easier to learn by annotating a paper handout. So it's a perfectly useful thing to want to do. Yeah, hopefully that answers your question. You'll need to ask through the teaching office of the department if you particularly want them to print those lecture notes to hard copy. I can't organise that because I don't go into the department at the moment because of the dreaded coof. Sorry about that. So let me go on with my comments. I've talked about what resources there are and where you can find them. I just wanted to ask something about recommended reading for the course. So at the start of handout 1, there is a page on some recommended reading. Let me just say, this is not needed. This is very optional reading. All of the material which you need to cover is in the handout 1. And the recommended reading is, in case you don't like the way I explain something in the, handout 1 and 2, if you don't like the way I explain stuff in the handouts and you want alternative textbook explanations, here are some recommendations. If you want a general corrosion textbook, you either want, it's a bit dated, but you want M.G. Fontana's Corrosion Engineering. That covers everything that you'd expect to find in a undergraduate corrosion course, actually at more detail than you need for this short 8-lecture course. Much more modern than M.G. Fontana, if you look at the bottom of the recommended reading at the online course material from the Materials Science and Metallurgy Department, they have their Do It POMS website. That has some very nice material, I think, on electrochemical corrosion. If you don't want a general textbook and you want explanations of the algebra that you're using, or you want more worked examples of the algebra, then maybe recommended textbooks 6 and 7 might be for you. In particular, some undergraduates have said they found the Zaki Ahmad's book number 7 to be friendly and approachable, and it gives quite a lot of worked examples of thermodynamics and electrochemical corrosion algebra. So that might be helpful as an introductory level. Reference 6, Adrian Fisher's Electrode Dynamics, is at a much higher level. You would only it goes far beyond what is in the electrochemistry of this course, but if you take chapters 1 and 2 of his book, that might give you an alternative way, where it's just a different write-up of how you look at the thermodynamics and electrochemical algebra of corrosion. Great. So I've been now through recommended reading just to say that it's recommended options that you do not need, because everything you need is in the PDF handouts of this course. And I've also said what is in the course, where do you find it, including the video lectures. So I hope that you will find the video lectures useful. Do give them a like if you do. Well, you don't have to. If you have questions that you desperately want me to answer in this stream, post them in the chat now, and I will sit and I will sit for a minute, and if I could remember any stories, I would tell one, but I can't. I will wait for any questions that come up in the chat. If there aren't any, but having watched the video lectures over the next month or so at your own leisure, you want particular topics explained, post them in the comments of this video, and I will try to address them in an upcoming video stream. I think my technology skills are not up to the task of inviting people to join me on the stream if you yourself are a streamer, but if you'd especially like to, in order to explain a complex question which you want to do as a dialogue, I will look into doing that. But we might have to schedule it late some night so we can record it, and then delete it if it goes horribly wrong. I don't see any questions coming up in my chat, so I will, in that case, leave the stream there. and hopefully you can enjoy the course by video, and you can post any questions and I'll deal with them in the future. Thanks very much.